Hello, y'all, and welcome to the Honors Math 112A notes. We're going to go over imaginary numbers today. And what you need to know right now is that an imaginary number is going to be a number with the letter I in it. So it has a letter I in it, and sometimes there'll be a constant B, alright? Remember, a constant is any number, whether it's a fraction, a decimal, it can be rational or irrational, but it has to be a number, okay? No variables. All right, so what exactly is I? So we're going to call I the square root of -1. Now, you think back to middle school math, you know that you can't square root a negative, right? Well, that's where imaginary numbers come into play. With imaginary numbers, you can take the square root of a negative. And that's why it's imaginary, right? You can't actually take the square root of a negative, but in order to make the rest of our math work, we have to think about taking square roots of negatives. And that's where I comes in. So basically what you need to know is I is the square root of a negative, and we use it in order to do more advanced math that you couldn't do if you didn't have the square roots of a negative. All right? So let's go ahead and figure out what exactly all these different exponents right here are. Alright? So the first one, I squared. That's the same thing as substituting our original value for I, right? And then we can square it. Alright. So when we square a square root, what happens? We cancel out the square root and then square it, right? So we're left with just -1. Perfect, right? Alright. And then for I3, we're going to do something similar, but we're going to use exponent rules. So if we recall from exponent rules, which was a few units ago, I know, we're going to break this up into I2 and I1. Alright, and the reason we do that is the 2 plus the 1 equals the 3, right? So it's accurate. We were adding exponents when you multiply. And by the same front, we can then, again, substitute our answers, right? So I squared was -1, so we can plug in -1, right? And then I to the 1, we can just write as I, right? And so a really simple way to write that is the 1 goes away, it's invisible, and we're just left with -I, okay? Then our last step, we have I to the 4th power. Now I to the 4th power, we could rewrite as I squared times I squared. And again, we're doing that because we know what I squared is equal to, right? It's equal to -1. So when we substitute -1 in for each of those I squareds, we can just do -1 times -1. And a negative and negative give us a positive. 1 times 1 is 1. So we're left with +1, right? And the reason that we have this set is that we never, ever want to leave an exponent on an imaginary number. So I want to have that written down right here for you. Never leave an exponent on an imaginary number. And remember, an imaginary number is any number, any term that has an I in it. Think I for imaginary, okay? And the way we're going to start simplifying these and the way we're going to get rid of these exponents is through something similar to substituting, right? So what we're going to do here is we're going to substitute for I5, right? We're going to say I5 is equal to, I'm going to do this in blue here. I5 is equal to, actually, let's do this blue. I5 is equal to I to the 4th times I to the 1, right? Because again, by product rule, 4 plus 1 is 5, right? When we add exponents when we multiply numbers. And then I know what I4 is equal to, right? It's equal to 1. And that's the easiest thing to multiply. That's why I went with 1, I to the 4th, because I know it's equal to 1, right? So then that's equal to, if I substitute that in, 1 times, we know I to the 1st power is just I, right? So I could rewrite this even over here as I, right? We don't need to substitute in the square root here. We're just going to deal with i's, alright? So no square roots, okay? So from here, we get 1 times I, right? And that's just equal to I. So I to the 5th is equal to I. Easy, right? Alright, let's try that with I to the 6. So this time, we're going to substitute in what? What do y'all think? Sorry, there's no one here. I to the 6 is equal to I to the 4th times I to the 2nd. And again, we're just trying to use the 4th because we know I to the 4th is equal to 1, and we know 1 is super easy to multiply by, right? So I to the 4th, we substitute that in, we get 1. What's I squared equal to? Negative 1, right? So we're doing 1 times negative 1. Remember, we need parentheses whenever we have a negative, right? And parentheses just mean multiplying. Then 1 times negative 1 equals negative 1. Super easy, right? So all we're trying to do is find the biggest groups of 4 that we can. Alright, so for I to the 7, for instance, we can make that into a group of 4, and what's left over? A group of 3, right? Because it needs to be 4 plus 3 equals 7. So 7 minus 4 equals 3. Perfect, right? And so from here, what we can do is plug those values in, right? So I to the 4 equals 1. Let's plug that in, right? I to the 3 equals negative I. Let's plug that in. Alright, again, 1 times anything is just itself, so we're just left with negative I. Easy peasy, right? Alright, let's try I to the 8th. I'm going to give y'all a second. You should pause the video and try this one by yourself. I'm going to go ahead and do it right now, though. So make sure you try to pause the video and do it yourself, alright? Okay, so from here, I to the 8 equals I to the 4 times I to the 4, right? And there's nothing left over in terms of grouping things by 4. Just I to the 4 plus 4 equals 8. Alright, we know 4, I to the 4 equals 1, so we're going to substitute that in. That's 1 times 1, and we all know that that equals 1. So I to the 8 actually equals 1, right? So as you can see here, sometimes we're not going to get an I in our final answer, right? And it's not actually an imaginary number anymore because there's no I. And that's okay, right? So we're simplifying and we're finding out that this imaginary number, right, that had an I at the beginning, isn't actually an imaginary number once we simplify, okay? Alright. Now it gets a little bit trickier here. Let's question why that is. Well, 22 is a much bigger number than any of the numbers we were working with before, right? So there are 2 ways to do this, and I'm going to break down what we're going to do in each, alright? So the first way to do this is the way we've been doing it up until now, right? I to the 22 equals I to the 4 times I to the 4 times I to the 4 times I to the 4. That's 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. I need one more. There we go. 20, and then I have 2 more left. I squared, right? And then when I substitute that all in, each of these I to the 4s is going to be 1. So it's 1 times 1 times 1 times 1 times 1. And then I squared equals negative 1. So our final answer is negative 1, right? And that works, but it's starting to get a little bit tedious, right? It's getting a little long. So pause here and double check if you need to, that if we added up these exponents, that would equal 22, right? And we're using groups of 4 again because we know a group of 4 is easiest because it equals 1, right? And that makes it really easy to multiply. You could have done this in groups of 2s, you would have just had a lot of negatives, or in groups of 3s, and you would have just had a lot of i's you would have had to figure out, right? So that's why this is the easiest way to do it. But there's a trick here, and some of y'all may have already figured this out. The trick here is to instead use division, right? So we're trying to see how many 4s we can put into something, right? Why not just do division? That's the definition of division, right? Because all we really care about is this 2 right here, right? All of these 4s cancel out. And that 2, that's equivalent to the remainder, right? Remember remainder from long division? We don't? Well, here is a quick refresher, if you will. So for long division, we're going to put how many times 4 goes into 22, right? So 4 goes into 2, 0 times, right? So we'll have to add the next number. 4 goes into 22, 5 times, right? So 4 times 5 is 20. So we subtract 20, right? Just long division. And we're left with 2. We have nothing more to bring down, right? So 2 is our remainder, right? Alright. And so the thing is, this remainder, right, is what's left, right? So At the end of the day, we could say I to the 22 is equal to I squared, right? And again, that's because we took all the way 5 groups of 4, and we said those are just equal to 1. We don't care about them, because 1 times anything is itself. All we care about is the remainder, right? And that's I squared, right? And we know that I squared, going back to our chart, equals -1. So our final answer is actually -1. Okay, take a moment. I know that's a lot. It's a very weird process what we just did. And I'm going to write it down up top, and then we're going to talk about it tomorrow, okay? All right, so divide the exponent by 4. Or rather, perhaps a better way to phrase this is, replace exponent with remainder. Then substitute. So those are your steps, right? First, we did long division to find the remainder, right? The remainder was 2. We took this 2 and we substituted it in. So instead of 22, we had 2. And then we simplified to -1. All right? And that's the process we're going to use every time. So if the explanation isn't sinking in with you right now, that's okay. Give it some time to let it sit in the back of your thoughts, and eventually it'll get there. In the meantime, that's the process we're going to do. This right here is the process, okay? All right, so let's try it with number 6, okay? That's going to be the same thing here. We're going to do long division. Now that you don't have to do both types, there'll be a little bit more space. So long division, right? All right, so 4 goes into 3, doesn't work. 4 goes into 31. All right, well, 4 times 6, 24. 4 times 7, 28. That's probably it, right? Because 4 times 8 is 32. Too far, right? So we have to go back. 4 times 7, 28, right? Because we can't go over, all right? And then we subtract these, and we're left with a remainder of 3. And remember, that is our remainder, right? All right. And so if that's our remainder, what are we going to do with that remainder? We're going to plug it back in, right? So we're going to take I to the 31, and we're going to say, no, it equals I to the 3rd, right? We're going to say it equals I to the remainder, all right? And I to the 3rd, we're just going to go back up to our chart. It equals -I, right? That equals -I. So we divided, we used our remainder, and we put it in, and we substituted, right? All right, let's try the next one. This one's a little bit different, but not much, okay? If y'all don't mind if we need a different color. So we're going to do 4 into 100. There we go. That's a little bit sharper on the screen. All right, how many times does 4 go into 10? 2 times, all right. So that means 4 times 2, we subtract the 8, and we're left with 20, right? Or 2. Then we bring down the 0, right? That was a bad arrow. There we go. All right. Better arrow. We bring down the 0. All right. And we're left with 20. All right. How many times does 4 go into 20? Hopefully remember our times table. So it's 5, right? So then we subtract 20. And we're left with a remainder of 0. Now what do we do when the remainder is 0? All right. So this is going to see if y'all remember your exponent rules here. Remember, anything to the 0 power is what? It's 1. It's 1, okay? So that is a really easy one. Anything to the 0 power, including I, is 1, okay? So if that's something you need to remember, maybe write it up top. Say note to self. I to the 0 equals 1. If that's something you're going to forget, okay? If you're not going to forget it, don't worry about it. That makes sense? That's one more thing that we might need to substitute or use our power rules for. Okay? Alright. I'm going to do one more, and then I'm going to hope that y'all work on your own, but I'll make sure I have the answers so you can check them, okay? So, let's try number 8. 4 goes into 38. Alright, does 4 go into 3? No, it does not. 4 goes into 38. Let's see. We know 4 times 10 is 40, right? But that's too big. So let's go down one. 4 times 9 is 36. Perfect. Alright. So we're going to subtract. We're left with a remainder of 2, right? Because there's nothing else to bring down. So there's our remainder. And if you don't remember long division, that's what this is called. Long division, right? Where should I write long division? Perhaps over here. Okay? If you don't remember long division, this is something you can look up videos on, or you can ask your teacher for help with. Alright? Long division. Okay, I know it's been a while for some of you. A lot of y'all are used to using calculators now, but this is a little bit harder with a calculator. Not impossible, but harder, right? Because there's not really an imaginary button on your calculator. That wouldn't make any sense, after all. Alright, so, remember we take I-38, we replace the exponent with the remainder, which is 2, and then we substitute. So I squared, we substitute our I squared value, right? Because, remember, we don't want any exponents. So we substitute I squared, which is -1. So we say I squared equals -1. Perfect. That's our answer. Easy as pie. Okay? It's always a good idea to make sure your answers are super clear, that your poor teacher, aka me, doesn't spend 2 years trying to find your answer, right? Not that I was consistent in doing that. Alright. So this is a good time to pause your video and go ahead and work through the rest of the answers. Then I'm going to have them work through on here, and if you have any questions, you can go ahead and look at each of them, alright? Alright, so here are my answers. Hopefully this is what you got. If it's not, double check your division and make sure you're dividing first and then substituting correctly, okay? Also, these answers should be in the inked notes that your teacher has available and is hopefully given to you. Alright? If you have any questions at all, just let your teacher know what problem you're having issues with, and I'm 100% sure they will help you. Okay? Remember, this process that we've gone through here is the same thing that we did up here, right? It's just a lot easier when you get big numbers, right? Imagine trying to do the grouping thing with 401. That would never work, right? At some point, you have to switch over to division if you ever want to finish in time. So this is just a more efficient way of doing the same thing we were doing up here, alright? And this is the way that you should do, because it works every time. This only works with small numbers, okay? Well, this. Not this stuff. This is long division. That's fine. It's the same kind of stuff. Alright? Alright, let's flip over the page. Okay. So here we go. We're just going to combine like terms, just as if I was an x, right? So we know that -14 and -4, those add up to -18, right? And then, of course, we have our 12 and 8i, and those add up to 20i, right? Nothing to substitute here. We're done. Alright. Y'all go ahead, pause this video, and try it with number 26, okay? Just combining like terms, nice and easy. Now remember, the only difference is with subtraction, we have to carry over that negative, right? So it distributes to both of them. So what I like to do here is to rewrite it, because that way there's no chance you're going to get this wrong, alright? So rewrite it so it's -13 and -6i, right? We always have to do that when we have negatives. It's really, really important, and if you forget to do that, it's going to mess up the rest of your problem, especially when these get to longer problems, alright? So from here, same combining terms. 24 minus 13, right, gives us, let's see, can I do this in my head, y'all? Questionable. 11. There we go. And then 14 minus 6i, that's going to give us plus 8i. That's it. There's our answer. And of course, we should be being good and making sure those answers are very clear. Especially as these problems get more complicated and there's less space for us. Alright? So go ahead. This is a good time to pause the video and try doing the next one. Alright? Alright, so we're back. Hopefully we got this problem just like that. If you didn't, go ahead and check your work. Make sure you're adding and subtracting properly and distributing that negative. That's always going to be important. Signs are always going to be important. Alright, now here it gets a little bit trickier, but the basics are the same. We're going to start by multiplying like terms, right? So here what we're going to do is we're going to multiply the numbers, just like we would with variables, and we're going to multiply the variables. So negative 6 times 8 gives us solid negative 48, right? And then we have I times I, right? And that's going to give us I squared. Now the trick here is to think back to what we were doing before, right? So before, when we had an I squared, we would substitute, right? And so I'm going to write that table over here on the side. You have to remember this table. It's absolutely essential, okay? This is just too important. You can't forget it, okay? Alright, so knowing that, we're going to substitute for I squared. We know I squared is equal to negative 1. So we're going to plug that in there, right? We're still going to keep the negative 48, right? And then when we multiply those two, what do we get? We get a negative times a negative is a positive. So we get a positive 48, right? Excellent. Alright. Why don't you go ahead and pause the video and try that with number 30, okay? Alright, so here again we went through the same process. We multiplied our coefficients or our numbers and we got 14. We multiplied I times I, right, and we got I squared. And then we simplified, right, so we substituted, sorry. We knew I squared was equal to negative 1 from our chart, so we substituted that in. And we were left with negative 14 because a negative times a positive is a negative, right? And remember, we are substituting. So this is our table for substituting, right? And we never want an answer with an exponent. That's absolutely not okay, okay? So absolutely no answers with exponents. If you need to write that up here so you don't forget, please do. Right? That's important. You should not have answers with exponents on an I. Right? If you have an exponent on your I, you can still simplify. You can still substitute, or you can still simplify and then substitute, right? Like we did on the front. Alright. So now, this is our good old buddy, FOILing. Y'all's favorite, I am sure. So if we recall, FOIL stands for first, right? We'll do in orange. And then outer, we'll do in blue. And then inner, which we're going to do in green. Which we're going to do in, what's a good color that's different for y'all? Pink? Let's do it. Alright, first, outer, inner, and last. Alright, good. So, for this first problem, I'm going to move to the center here, just for ease. I'm going to start with the first, right? That is these two. These are the first ones. We multiply those, we get negative 20, right? I'm going to rewrite that down here. Okay? And then we have to do our outers, right? So for that, that's going to be these two. Right? So that's 5 times 8i, right? 5 times 8i. And that's a little trickier. Remember, we're going to multiply the numbers together. So we'll get 40, right? Because there's no negatives, we'll make it a positive. And then we bring down the I. Okay? From there, we have to do our inners, right? And that's going to be these two. And again, with negative 4, times 6i. Remember, order doesn't matter with multiplication. And so we do negative 4 times 6, which is negative 24. Negative means that's going to be a minus sign. And then I, right? And then, of course, last but not least, we must do our last ones, right? And so here we have 6i times 8i. I know this is a lot, but I promise it's about as hard as it's going to get today, okay? So 6 times 8 is 48. Then I times I is I squared, right? So we have 2 i's in that multiplication problem, so we end up with an I squared, okay? This makes it a little bit easier here. Just put that in a little box over here. Oh my gosh. Okay? Good. Alright, so from here, all we need to do is combine like terms, alright? So we're going to combine the blue and the green, right? Because they both have the same number of i's. And we're left with 40 minus 24, which is indeed, what, 16i. Good. Alright, and then I'm going to bring down the other one. So we have plus 48i squared and negative 20, right? And let's just put that positive back in here. There we go. Alright, now here's the trick. I squared, remember, we never want an answer with exponents in it, right? And right here, that's an exponent. So how are we going to get rid of it? Take a look at our table. I squared equals negative 1. So we are going to substitute that in. Alright, so instead of I squared, I'm going to write negative 1. Everything else comes down. 48, I'm sorry y'all, but I got a little slanted here, plus 16i, and then minus 20. Alright, let me pause that and go get that. Alright, y'all, sorry about that. So from here, what we're going to do is, I think I forgot to bring down this plus. There we go. Alright, so from here, we're going to multiply, right? So 48 times negative 1 is negative 48. Hope you know that. Alright, bring down the other stuff, of course. Alright, and hopefully I'm not moving too fast. If I am, you can always just pause the video, right? Alright, and then from here, last step, we need to combine like terms again, because we have some new like terms, right? So we're going to combine those two. Negative 20 and negative 48 give us negative 68. Alright? So we have negative 68 plus 16i. Okay? That is our final answer. And it's important to note that these are called complex numbers, right? So complex numbers are like this one, or this one, or this one, or this one, right? A complex number has both a real number, and then it's added or subtracted, to an imaginary number, a number with an I in it, right? And this is just a real number, right? This is just a real number. But this is a complex number, because a complex number has both. So go ahead and write that down somewhere, just so you know that, right? I'm going to go ahead and write it here. Okay? Complex number is a real number plus an imaginary number. And we write that, you're going to use proper form as A, where A is just a constant, plus BI. Remember BI from earlier? Now it's A plus BI, alright? And the order is really important here. So we have the real number first and the imaginary number second, alright? So think about it like you have an order for standard form, x squared, x, and so on. Here, our order is the real number and then the imaginary number, okay? Alright. And you'll see, so all of our answers are going to be in that format. Sorry, this yellow is weird, but it's negative 68. There you go. You can see that. Okay? Alright. So, from here, let's go ahead and try 32. I'm going to do this one with you again. Alright? These can get a little tricky. There's a lot going on. Alright? So, again, we're going to start with foiling. Alright? So, we're going to do the first ones. Right? And when we multiply those, 3 times negative 6 gives us negative 18. Hopefully you remember that. Good. Negative 18. And then after that, we have the outers, right? And that's going to be these two, right? All right. And the outers are 3 times 2i, right? 3 times 2 gives us 6. Don't forget the I. Good. And then we have the inners. It's going to be these two, right? And those two give us negative times a negative is a positive, important, right? So we have positive, and then 6 times 7 is 42, I hope. All right, and then remember we have the I, so we're going to add it in. All right, don't forget it. Don't mess up your problem. All right, and then we have our lasts, right, which are these two. All right, so we multiply those together, and negative 7 times a positive 2i, and negative times a positive gives us a negative, right? And then 7 times 2 is 14. And then we have 2i's, so we're going to write it as I squared. Just like if we FOIL, then we have x times x, we get x squared. Okay? From here, now we're going to combine like terms. So that's these two, right? And when we combine those, we get a nice 48i. Right? And now what I'm going to do is what took us 2 steps last time. I'm going to do in 1 step. So here we look and we see we have n, I squared. We know from our chart the I squared equals negative 1. So I'm going to replace that with a negative 1, right? And when I do that, when I multiply negative 14 times negative 1, I get positive 14. Alright? So I get a positive 14 there. And then I bring down this negative 18, right? Alright, and then our last step, right? Because we just did that substitution, now we have more things that we can combine, right? And I'm not going to do it in yellow again because that didn't work so well last time. I'm going to keep it in orange here. So we can combine these two, right? When we combine negative 18 plus 14, we get 4. And we get 4 plus 48i, right? Alright, and that's our final answer, okay? So we're just foiling here. And remember that we want it to go real number, then imaginary number. Real number, then imaginary number. So the I should be at the very end. Okay? Alright. If you feel comfortable, go ahead and pause now and do them yourself. Alright? If you don't feel comfortable, I'm about to do 33 and 34 with you. So, we're going to multiply the first ones, right? And positive 15 times negative 11 gives us a nice negative 165. I would probably use a calculator on that if I hadn't already done this problem. 15 times 4 gives us a solid, 60? 60, and then don't forget our I, so 60i. Alright. And then we have our inners, alright, that's going to be these two. So, 2 times negative 11 gives us negative 22. And then we don't forget our I. Alright, and then the last, probably the trickiest, and honestly it's not too tricky the more you get used to it. Alright, 2 times 4 is 8. So it's a positive times a positive is a positive. And then I times I gives us I squared. Alright, now we are going to start simplifying. So from here we can start by combining like terms, right? These two terms in the middle have one I each, so we can combine them, right? Think of it just like a variable. We can't combine things without variables and with variables, right? Combine things with the same number of variables. So 60 minus 22 is 38. 38i, right? Good. And then remember here, we never want an I squared, right? So what we're going to do for the I squared is instead substitute what we know I to be from our little chart here, which is negative 1. I squared equals negative 1. So, I'm going to cross this out and write negative 1. Right? And when I do that, when I multiply 8 times negative 1, I get negative 8, right? So honestly, an I squared is always going to change the sign right here. If that is an easier way to think of it. Then bring down my negative 165. Can't forget it. Haven't done anything with it yet. And finally, we are going to combine like terms. So when we combine these two, we get negative 173. And remember, our real number always goes first. Alright? real number, then imaginary number. And voila, it's done. See? That wasn't so awful, was it? Alright, let's do the next one. Alright, so we're going to start with our first numbers, right? 2 times 10. And that gives us a nice 20, easy, right? And then we're going to do our outers. That gives us 2 times negative 6, right? Which is negative 12. And then don't forget the I. Okay. And then we're going to do our inners. That are these two, right? Negative 5 times 10 is negative 50. Good. And then don't forget the I again. Alright. And then we're going to do our lasts. Alright, so for these two, negative 5 times negative 6 is positive 30. I times I is I squared. Okay? Now, what's our next step? Say it like there's anyone here to answer me. We're going to combine like terms. Alright? So, we can combine these two because they have the same number of i's, right? This has 2 i's, can't combine it. These both have 1 i, so we can combine it to a nice negative 62i. Don't forget that negative, right? Since they're both negative, just making it more negative. Alright, then remember, we never ever want an I squared. We never want an exponent in our I. We know that I squared equals negative 1 from our table. And that's something we're either going to memorize or we're going to logic in our head, right? Square root of negative 1 equals I. Alright, so then we'll have plus 30 times negative 1, which makes us might be negative 30, right? Positive 30 times negative 1 is negative 30. There you go. And then we're going to bring down our 20. Alright, and from here, we can just combine like terms. So that's going to be this guy and this guy. And 20 minus 30 is negative 10. And remember, we want the real number to go first every single time. Alright, real number minus imaginary number. And that's your final answer, so you can put it in a box. Negative 10 minus 62i. Easy peasy, right? Alright. So these two I'm really going to let you do on your own. Go ahead and do them, and then in a second, you will see my version, and you can check your work. Alright, so there are my final answers for the last 4. Hopefully, you all notice that there's some extra canceling out here, and we actually end up with real answers, right? There's no I anywhere in that answer. So these are real numbers, whereas these were complex numbers, and up here, well, all of these are complex numbers, but what we had on the other side were imaginary numbers, right? Because they didn't have a real number added to it. So over here, this, for instance, is an imaginary number. But here, we have real numbers, right? And that's because the i's all canceled out. Alright, so if you thought I was playing a trick on you, maybe a little bit, but hopefully you got the right answer. And if you didn't, I want you to go back and check your work. And again, ask your teachers. We are here for your e-learning day to support you. Alright? Okay. I am going to finish this video, but definitely go ahead and do your 12A practice right now. This sinks into your head so that you're ready for 12B tomorrow, because it gets a lot tougher real quick. Alright? Alright, y'all have a good day.